Well, good morning. It's so dark 30 out here in the shop. Nice comfortable 53 degrees outside. And I came out and did a little bit of setting up early. First thing, I've got a 16-inch rotary table that I set onto the mill. And then I got the small piece of cast iron off of the lathe and centered it on the table using the rings that are on the top and just using a scale to go around making sure it's roughly center. Again, there's nothing critical about anything that I'm going to be doing over here. All we're going to do is drill 3 holes in it, and these 3 holes are to line up with the 3 holes here. Now, when I measured these are not evenly spaced around here. The distance from this hole to this hole is equal to the distance between these 2 holes, but this one is smaller. So we've got an isosceles triangle there, not an equilateral triangle. So I had to go back and remember my 8th grade trigonometry and get a couple formulas, do a couple calculations on that, and also figure out what the angles are going to be on the rotary table. So basically we're going to drill a hole at 0, a hole at 117, and a hole at 242, more or less. And the radius coming out is a little bit over 9 inches. I'm going to check with my calculations, get the exact numbers. The first thing to do is to locate the center here, and what I use and to do that is just a little spring plunger, and I'm just using it as a pointer. And to hold it on this mill, it's going to go into a collet. I've got an ER collet, and these just snap in. So basically just drop in like that, and then I can thread it on. It's kind of a fine thread, so sometimes it takes a little bit to get it started. Put my plunger in there, crank it down. Now, since I'm not meaning to do any torquing on this, I don't necessarily have to go out, get a wrench and tighten it down tighter, so I'm not going to do that. What I'm going to do is fire up the phase converter, bring it a little bit closer. I'm going to come in, and yesterday before I took it off the lathe, I did this off camera. I broke this edge here, and I just touched the center very lightly with a very small center drill, just enough to make a mark in the middle that I could use for lining up here. So we're going to line up on the mark. We're going to lock the y-axis of the table. We're going to come out the radius, which is roughly 4.5 inches. And then I'm going to swap this out, put a drill in, and when we put the drill in there, I believe it is 27/64, so it's going to be a 1/2-13 thread. That's a little bit smaller than what's here. These are 5/8 11, but this whole area is going to get milled out later, so it doesn't matter. So I'm going to have a 1/2-13 thread in there, Morse taper drill, and just put it in a Morse taper holder, set it up in there, and then I'll drill the 3 holes. Before I drill the holes, I'm going to go through and just lightly mark them, and then I'm going to use the template that I've been using, which I've gone up here, and I've got Sharpie marks on it where the holes are. So one at the top, it's fading a little bit, one over here, one over there, and then I'll be able to just basically check to make sure that I've got the holes in the right place. If anything looks too terribly off, go back to the drawing board, start all over again. So I've got my blank center. I've got it clamped down nice and tight. It's heavy. We're drilling a small hole. It's not going anywhere. Probably just sit here, but I don't, as I spin it around, I don't want to move it around on me, so I've just got a couple clamps on it. So that's the basic plan for today. I'm going to bring you in close. I'm going to fire up the phase converter and get to work. Okay, my radius is 4.55359 by calculation. Got the DRO of 4.335. If you expect it to read any closer than that, you're really kidding yourself. Put my drill holder in. I should say my Morse tape or adapter. Now I'm going to be feeding this with the vertical feed. We'll lock the table in both X and Y directions. We're going to feed upward. Half-inch drill. Speed works out to be somewhere around 450. Closest that I've got 310 or 490. So I'm going to go with the 310. So I've got my lever set for that up here. Okay, 310 RPM on the calculator. Line that up with the number of teeth. And on a drill, that's 2. And then I'm looking down, probably want 5, 6, 7 thousandths of an inch, somewhere around feed rate of 3 or 4. But the vertical feed is half of what it reads on the dial, so I need to double that, go up to maybe 6. Another way I could do that is pretend that I have 4 flutes on the drill. Set 310 off this at 4 flutes, and just go down there, and 5 thousandths again, I'm reading about 6.2. I've got a setting of 6 1/8. That's close enough, so I'm going to go vertical at half of 6 1/8 per minute upward and locate the hole. So first thing I'm going to do on this is I'm going to spin this around once, and just to make sure my holes are in a sensible place. First I'm going to bring the table up a little bit. one of the reasons I made the template was to check things, and I thought that there was an error there. And so I went back and looked at my calculations. There was nothing wrong with the calculations. The problem is when I indexed 242 degrees, I misread 212 down here. The 210 and 240, just misread it, so I had this marked 30 degrees off. This is the correct one. So when I went back and respun it to check things, now everything lines up with my template. I'm happy with it. So I'm going to fire the phase converter up, and I'm going to drill 3 holes. I'm going to start with the one that's at 242. It's actually 242 degrees, 11 minutes, 9 seconds is what's calculated. I can dial 10 seconds in on here, and that's way more accuracy than what I need for what I'm doing at the moment. But it is nice to just notice, keep that in there and remember it. So I'm going to drill that hole, then I'm going to drill the hole that is at 0, and finally go around. Third hole is at 117 degrees, 48 minutes, 50 seconds. It's actually 51, I could read 50. So just going to go through, going to do the power up feed on these. I've got 6 1/8. That's what's calculated out. The actual up feed is half of that rate. I've got the speed set, and it's at 310. The calculator for cast iron, I could go a little bit faster on that, but I'm not going to do that. I did look up the numbers. Ductile cast iron actually can be machined faster than gray cast iron. The 65, 45, 12 with high-speed steel. For turning, it's 100 feet per minute. For the ASTM 50 gray cast iron is 60, so I could actually go much faster. So I'm running a little bit less than the optimal speeds, but it's enough that things will be cool. I'm not worried about this part overheating. Should be removing chips well, so it should be okay. And being a cast iron, I am going to machine this dry. So, fired at the phase converter. Probably not going to say anything until I'm done with these 3 holes. So I'm going to move this out of here and I'm going to tap these holes by hand. I don't have a way to really control the feed. Power tapping through here, this is fixed. It doesn't have a sensitive quill on it or anything like that. And it's not worth the trouble of taking it over to my other mill. So I'm going to hand tap these and then we'll go on to the next step. I thought I made a mistake once, but I was in error. I don't know that I can say that anymore. So I put the template down here and the holes are not quite aligned where I wanted them to be. And I went back and I looked at my calculations, thought maybe those were wrong, and there is a small error in there. So the holes are a fraction of a diameter off of where I want them to be. So I went in and decided to think about this because this is something that's like, how do I want to deal with this? So there's about 3 different ways that I thought of to deal with it. One is to reverse this end for end over what the original use was. The second is to go out later and see if just the width of the wider slot that I'm going to put in here makes up for the difference. And that very well may do it. And the third is just when I move the slots, move them over to the spaces between the holes, possibly mill that away as a cosmetic improvement. That's probably what's going to end up happening. So the net result of it is they're not way off, and that's why with this sitting up above, resting on the studs before, I didn't notice it. But they also are not exactly where I wanted them to be. But it's not going to stop me from going forward, so I'm going to move on to the next step. I'm going to get this off of here and go to the next stop and still use the dimensions that I had because I'm going to machine 3 holes in a faceplate to line up with these, and then I'm going to be able to remount this on the lathe and then proceed the way that I originally intended. But it's really, really disturbing that I can't ever tell many people now that I've never made a mistake. Now, what the heck? I'll just lie to them. Okay, brought my faceplate over. I set it up, space it out. It's got the studs on the back, so I need to lift it up a little bit. So I've got it resting on a couple 246 blocks. Clamp down. And what I'm going to do is drill a hole here, and I'm going to use this existing hole. I had to play around a little bit because there's a rib right underneath where this rule is, and this is going to come down right beside it, so when we're done I'm going to have to flip this over and mill out a little space for the nut. But there just seems to be no way around it. So basically it's still going to be a vertical feed. This is centered on here. Got an indicator over here. When I spin it, I'm within 1/1000th of an inch the whole way around. That took a little bit of doing, but it's all set up, should be running smooth, and the only concern that I have right now is this is just going to be real close. It's kind of a small rib in there. It's not really doing anything too structural compared to the thickness of the web. It's insignificant. I don't know whether they just thought it looked nice or what the reasons for it were, but there's one of those between alternate ones of these, and there's just simply no way to get around it. The point over here, it's actually between these two, so there's no rib here. I won't have a problem there. So I'm going to fire up the machine, and I'm going to drill this the same way as before, vertical feed. I haven't moved the table any, so I'm still in good shape for that. And let's get to it. Now I'll clean up, deburr the holes, flip the faceplate over. Okay, I've got an 1.5" carbide cutter in here, just because it happens to be the right size. Don't have a high-speed steel one handy, already set up. This is just a cut that's just kind of by eyeball. I'm still on the same radius. What I'm going to do is rotate the table in. I've got all the hydraulic power feeds turned off because I need to watch out for these studs. The one back here might be hitting. It looks like it's got clearance. So what I'm going to do is I'm going to feed the table vertically by hand until I just start skimming here, and then I'm going to go across and turn it in until I get the cutter roughly lined up with the hole, and then back it out. So that'll give me a place I can put an 1.5" diameter washer. So for 1/2" nuts, there should be plenty of room there. So let's do the cut. Okay, I hear it skipping in. One thing I don't like is this is throwing the chips towards me, so I'm going to put guard up. Okay. Plenty of clearance. And that looks like it'll work for what I'm after. So I mounted the cast iron blank onto the faceplate and centered it a little bit. As you can see, it's running true at the moment. Got maybe a half a thousandths to a thousandth to run out. And this is a non-critical face on here where I have it. That's just cosmetic. So from this point on, we've actually got some things that need to be lined, but they're all internal. So I'm going to start and drill a hole in the end, and then I'm going to start boring out the inside to get it to the dimensions I need. And to do this, I will need to flip this around at some point in time and get the other side, but that's going to come later. So let's get to it.